In this video, we will understand the effect of location of the pole on the steady state error, the response, as well as the settling time, or indirectly the speed of the system. So I have taken 5 systems. So this is S plus 2 by S plus 5 is system number 1. Then S plus 2 by S plus 2 divided by S plus 3 is system number 2. Similarly, S plus 2 divided by S plus 7, S plus 3 divided by S plus 5, and S plus 1 divided by S plus 5. Now, each of these, we have for a unit step response, for the unit step input, the response C of t is calculated, and the corresponding steady state error and the settling time, which is equal to 4 into t, that is time constant. The t is also given as 1 by a, where a is nothing but the pole location here. So fine, it is the pole location in this case. So we have calculated this. So first we will understand the effect of pole location. For that, I'll consider system number 1, 2 and 3. So I can see that first we will understand the steady state error. So the steady state error of system number 2, that is ESS2, is less than ESS1, which is less than ESS3. So if I plot this curve, this is the S plane. So this is -3, -5 and -7. So this is for system number 1, 2 and 3. So here you can see that as we move away from the j omega axis, the steady state error is increasing. So you can see that for S is equal to -3, it is 0.33. You can find here. This is the second system. The first line, the blue color, this is the second system. So you have only this much steady state error. And this is the first system and this is the third system. The red color is the first system and the green one is the third system. So you can see as we move away from the j omega axis, this is the j omega axis. As we move away from the j omega axis, the steady state error is increasing. That is the first inference we can make. We can make if for S is equal to -3, you have this much steady state error. For S is equal to -5, this is this total distance from this point. This is the desired. The yellow color line is the desired input, which is equal to 1. Fine. So from for S is equal to -5, this is the steady state error. And for S is equal to -7, your steady state error is much higher comparatively. So that is the first inference we are making. Okay, the second inference what we make here is with respect to settling time. So settling time will actually tell us the speed of the system. So you can find that from the graph, you can find from the table, you can see that your settling time of third system is less than settling time of first system, which is less than settling time of, sorry, yeah, just a minute. There was extra one there, fine. Okay, so settling time of third system is less than settling time of first system, which is less than settling time of second system. So this one, you can find that for third system, where S is equal to -7, your settling time is around 0.5714. And next for S is equal to -5, it is around 0.8. And for S is equal to -3, it is around 1.33. So here you can see that as you move away from the j omega axis, the settling time is actually decreasing. The speed of the system is actually decreasing. Okay, the speed, sorry, not the speed is increasing. The speed is increasing, or the settling time is increasing. Whereas for steady state error, as we move away from the j omega axis, the steady state error is increasing. So this is one of the limitation whenever we are designing any system. So if you want more speed, you need to locate the pole as far as possible from the j omega axis. But when we do that, it will eventually increase the steady state error of the system. So you cannot move just because to attain high speed, we cannot move the system much farther away from the j omega axis. Similarly, just in order to have lesser steady state error, we cannot place the pole much nearer to j omega axis because that will eventually decrease the speed of the system. So the first inference that we are making here is that the first one, as we move away from, as the pole, sorry, I'll just rewrite the sentence. As the pole location, as the pole location is moved away from j omega axis towards left. So this is important. Moving away but towards left. So the steady state, the first one is the steady state error increases. The steady state error increases. And the second one is that the speed of the system increases. The speed of the system increases.